We're given a polynomial function f of x equals x to the fifth plus 3x cubed minus 4, which can be written as x to the fifth plus 0x to the fourth plus 3x cubed plus 0x squared plus 0x minus 4. Suppose I want to evaluate the function at -2, which means this is how I could do it. Minus 2 to the fifth power plus 3 times -2 to the third power minus 4. And that's how I would evaluate the function at x equals -2. However, we could use synthetic division and or even long division to figure out the value of the function in a slightly different way. And this is how I would do it. So I want to write f of x as x plus 2 times q of x plus the remainder, which is not a function of x, it's going to be a constant since I'm multiplying with x plus 2. The degree of the remainder is 1 less than the degree of the divisor, so the remainder will be of degree 0, which is, it's going to be a constant for sure. So if I can somehow write the function as x plus 2 times q of x plus r, then f of -2 is equal to -2 plus 2 times q of -2 plus r. -2 plus 2 is equal to 0, and 0 times anything is 0, so we're left with r. So the remainder that we get by dividing the given polynomial by x plus 2 is the value of the function f of -2. And you might say that this is a roundabout way of evaluating the function, but this helps us better understand the remainder theorem. So let's use synthetic division to find the quotient and the remainder. So this is how we do the synthetic division. If I were to plug in a -2, if the remainder is 0, then that would mean that x plus 2 divides the function f of x, the polynomial function f of x. So what I'm doing now is synthetic division. So it's 1, which is the coefficient of x to the fifth, coefficient of x to the fourth, coefficient of x cubed, coefficient of x squared, coefficient of x, and the constant term. So -2 times, first bring the 1 down. -2 times 1 is, I'm going to write it here, -2. I add these two to get a -2. -2 times -2 is +4. Add these two, so there would be a 7. 7 times -2 is -14. Add to get a -14. -14 times -2 is a +28. I add the 2 to get a 28. 28 times -2 is -56. And when I add these two, I get a -60. The last number in our synthetic division gives us the remainder. So basically, f of x can be written as x plus 2. Remember, in synthetic division, if x plus 2 is a factor, then x equals -2 is a solution. So remember that this is the number we use for the synthetic division, is the degree of the quotient is 1 less. So that's x to the fourth minus 2x cubed plus 7x squared minus 14x plus 28, and then minus 60. Okay, so now f of negative 2 makes this a 0. Anything multiplied with 0 is a 0. So we're left with a negative 60. Negative 60 is the value of the function at negative 2. So this is kind of a roundabout way of evaluating a function at negative 2 instead of simply plugging it in. But this helps us understand the process of division and how to write down a polynomial function using the remainder theorem.